Hello my friends, it's your NOLA Mathman here for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to perform operations with radical expressions. The concept we're looking at is radical expressions. The skill we're going to learn is how to perform operations with radical expressions. So with no further ado, let's get started with our math adventure. So our first group of problems, we're simplifying radical expressions involving addition and subtraction. First problem reads 7 times the square root of 7 minus 2 times the square root of 7. So when you simplify radical expressions, you're factoring out the common factor, which is the square root of 7, similar to what you do with distributive properties. When you factor that out, you're left with 7 minus 2, which is 5. And so the answer will be 5 times the square root of 7. So that's our first example. Again, we're factoring out a common factor like we do in distributive property. So let's see what we're going to do next. What's the NOLA Mathman going to go? We're going to go to number 4 when we have 3 radical expressions. We have the square root of 15 plus 8 times the square root of 15 minus 12 times the square root of 15. So what do you think the common factor is here? You guessed it, it's the square root of 15. So we factor that out. We write what's left in the grouping symbols. The coefficient is 1 when you factor out the square root of 15 plus 8 minus 12. And so you simplify that, and that will get us, we add the like terms, 9. 1 plus 8 is 9. 9 minus 12 is -3. And so our final answer will be the negative 3 times the square root of 15. So again, you take the 9 minus 12 and you combine that with the square root of 15. So what's next? So we've done our first group of simplification problems. Now we're going to go to another group of problems. And again, these look a little different. Now we have square roots that are variable expressions in addition to having square roots that are integers. And so I would assume we'll do 5 or 6. So let's start with 6 here. We have 9 times the square root of 6a minus 11 times the square root of 6a plus 4 times the square root of 6a. Now, even though we're dealing with variables, we still have a common factor. And what is that? What's the square root of 6a? So we will factor that out of each of the 3 terms. We write the coefficients that's left. 9 minus 11 plus 4. We combine 9 plus 4, which is 13. And we will subtract 11 from 13, and so, which will show up in a sec. NOLA Mathman is doing the calculations, and obviously 13 minus 11 is 2, and so your final answer is 2 times the square root of 6a. So again, we're getting into the process, again with addition and subtraction, you're doing like the distributive property. When they're common radicals, it's very easy. So now we're doing a problem where we don't have a common radical. As you can see, we have the square root of 28 plus the square root of 63. They're not common radicals. So you have to simplify the radicals using your property of radicals. So what you want to do is find a perfect square that's a factor. Perfect square that's a factor of 28 is 4, so you put 4 times 7. 9 is a perfect square, so you go 9 times 7. By simplifying the radicals, we take the square root of each of the factors. As you can see there, the square root of 4 is a perfect square, which is 2. So that the square root of 28 will simplify as 2 times the square root of 7. The square root of 63, because the square root of 9 is 3, will simplify as 3 times the square root of 2. Times the square root of 7, I'm sorry. Now you have a common square root that you can factor out the square root of 7. We're left with 2 plus 3, which is 5, and our final answer is 5 times the square root of 7. So once you get a common radical like we did in the first set of problems, we factor that out just like we did here. So now we'll go to the next group of problems to simplify here. Let's see what we do next. Now we go to problems 9 through 12. And so again, you have examples of radicals that don't have common radicants. We call the term under the radical. They have to be common to be able to simplify. So we'll start here with number 10. A times the square root of 54. Again, looking for the perfect squares that are factors of 54. Square root of 6 you can't break down. We know 54 is 9 times 6. 9 is a perfect square. And so we break it down into its separate factors. The square root of 9 times the square root of 6. 4 times the square root of 6 you can't simplify. Square root of 9 is 3. So now we will have 8 times 3 times the square root of 6. 8 times 3 is 24, so we'll have 24 times the square root of 6 minus 4 times the square root of 6. We can factor out the square root of 6, which is a common radical. In our grouping symbol, we'll have, in our parentheses, we'll have 24 minus 4, which is 20. And so your final product will be 20 times the square root of 3. You're simplifying. Times the square root of 6, I'm sorry. It's the square root of 6 because that was your common radical. So let's go to the next one. We'll now go to number 12. Again, we have the square root of 72 plus the square root of 50 minus the square root of 8. And again, since we don't have common radical values, we have to simplify each of the radicals as much as possible by looking for perfect squares. 72 can be broken down into 36 times 2. 50 can be broken down into 25 times 2. And 8 can be broken into 4 times 2. So now we take the square root of each of the factors. We have the square root of 36 times the square root of 2, square root of 25 times the square root of 2, square root of 4 times the square root of 2. You simplify the perfect squares, we will have 6 times the square root of 2, plus 5 times the square root of 2, minus 2 times the square root of 2. Now we have a common radical, which is the square root of 2. We factor that out. And in our grouping symbol, we'll have 6 plus 5 minus 2. That will simplify into 11 minus 2, which is 9 times the square root of 2. And that will be our final simplified answer. Very good. So we're done with number 12. And so we've done a variety of problems that deal with simplifying addition and subtraction radical expressions. So, and we got another group. We got some more. There's a lot of different varieties of addition and subtraction problems and simplified. So I want to cover as many different types as possible. So now we'll go to 14. We have 2 times the square root of 24 plus 4 times the square root of 54 plus 5 times the square root of 96. So again, at this point, we know we're trying to break down the radicals into a perfect square times a common radical factor that we can factor out. So with 24, we know 4 is a perfect square, so we write 4 times 6. 54, we know 9 is a perfect square, we write 9 times 6. And then for 96, we know it's 16 times 6. So again, we simplify each of these radicals. We write them as separate radicals. 2 times the square root of 4 times the square root of 6. Plus 4 times the square root of 9 times the square root of 6. Plus 5 times the square root of 16 times the square root of 6. You simplify the perfect squares, so we have 2 times 2 times the square root of 6. Then you have 4 times 3 times the square root of 6. Plus 5 times 4 times the square root of 6. You simplify the 3 products, you'll have 4 times the square root of 6. 4 times 3 is 12 times the square root of 6, and 5 times 4 is 20 times the square root of 6. Now you have a common radical you can factor out of the 3 sums, which is the square root of 6. You will have left in the grouping symbol 4 plus 12 plus 20. You add 4 plus 12 plus 20. What does that equal? That will give us 36 times the square root of 6, which is our final simplified answer. So again, we're doing the same processes over and over. You just want to take your time, make sure you get your perfect squares correct. So now let's go to number 16. This one looks a little different. We have 4 terms here. 2 times the square root of 13 plus 4 times the square root of 2 minus 5 times the square root of 13 plus the square root of 2. So what you have to do is we have some common radical terms. So we group those together, as you will see. We take 2 times the square root of 13 minus 5 times the square root of 13. We group that. And we take 4 times the square root of 2 and we add the square root of 2. In each of those two grouped like type radicals, we can factor out a common radical, which in the first group of terms is the square root of 13. The second group of terms is the square root of 2. We're left with 2 minus 5 in the grouping symbol when we factor out the square root of 13. We're left with 4 plus 1 when we factor out the square root of 2. We simplify that, we will get negative 3 times the square root of 13 plus 5 times the square root of 2. We put the positive term first. We go 5 times the square root of 2 minus 13, minus 3 times the square root of 13, which will be our final simplified answer. So that one, you have 2 different groups of like radicals. You put them together, just like combining like terms with algebraic concepts with x and y. You just look at the radical as a variable expression. So now we're moving to a different type of simplification problem where we're multiplying radicals together. And so we'll start with number 18. We have the square root of 5 multiplied by, inside the grouping symbol, square root of 10 minus the square root of 3. So we will simplify this using the property, distributive property. We have a term outside the grouping symbol. We write the general form of a distributive property, a times b minus c equals ab minus ac, or you can write it a times b plus a times negative c. So I typically keep it addition so you don't make sign problem mistakes with the subtraction. So I'll write it as a times b plus a times negative c, but you can do it either way. So we break it into 2 separate products. We have the square root of 5 times the square root of 10 plus the square root of 5 times the square root of negative square root of 3. We multiply the 2 radicals and create one big radical. So under the term, we'll put 5 times 10, then we create one big radical and we write negative, and we multiply 5 times 3. That simplifies the radicals, which is a property. So we will end up having the square root of 50 minus the square root of 15. You cannot simplify square root of 15. There's no perfect square as a factor. With 50, you do have it, so you break it down into 25 times 2. You take the square root of 25 and the square root of 2. That will simplify to 5 times the square root of 2 minus the square root of 15, which will be our final simplified answer. You have to simplify radicals as much as possible. So if you have a perfect square that's a factor, you have to simplify it as much as possible, as this problem illustrates. So now we will go to another type of problem using the distributive property here. We'll do number 20. So we have 3 times the square root of 3 times, in the parentheses, the quantity of 2 times the square root of 6 plus 4 times the square root of 10. So again, we'll do like we did in the last problem. We want to distribute this 3 times the square root of 3 into the grouping symbol and create 2 separate products. So we write above the problem, a times b plus c will give us 2 products, a times b plus the quantity of a times c. And so we're going to apply that to the radical terms. So we will have 3 times the square root of 3 times 2 times the square root of 6 plus 3 times the square root of 3 times 4 times the square root of 10. So again, when you multiply radicals, you multiply their like terms. So we will multiply 3 times 2. Then we will multiply the radical of the square root of 3 times the square root of 6, and we'll simplify that. And then in the other group of products, we will multiply 3 times 4, and we will multiply the square root of 3 times the square root of 10. Now, when you simplify all 4 products, you end up with 6 times the square root of 18, and you end up in the other products 12 times the square root of 30. So again, there are perfect squares that are factors of 18, so we find a perfect square, which is 9 times 2. We break the 18 into that. 30, can we break that down? No, we cannot, so we leave it as a square root of 30. So we take the square root of 9 times the square root of 2. Square root of 9 will end up being 3. So 6 times 3 times the square root of 2 will be the final simplified answer of that radical. And then we will add that to 12 times the square root of 30. And so our final answer, once we multiply 6 times 3, will be 18 times the square root of 2 plus 12 times the square root of 30. And so that is our final, most simplified answer to this radical expression. So we're done with number 20. So let's see what we do. Do we have any other different types of radical expressions to simplify? Let's see what the NOLA Mathman comes up with next. So now we got another group of problems. We have 21 through 24. These look a little different. We're not multiplying one term times two quantities. We're multiplying two terms by two terms. So this is a little different. So number 21, we have 4 plus the square root of 3 times 4 minus the square root of 3. So whenever you multiply polynomials, just like we do with algebraic expressions that are polynomials, we want to use the box method to multiply and get the 4 products. Since we have 2 times 2 terms, we should expect 4 separate products. And so we label our box 4 times the square root of 4 plus the square root of 3. That's the horizontal component, and the vertical will be 4 minus the square root of 3. So we multiply each separate term. 4 times 4 is 16. 4 times square root of 3 is 4 times square root of 3. 4 times negative square root of 3 is negative 4 times square root of 3. Negative square root of 3 times square root of 3 is 3. Negative 3, so we will cancel out the square root of 3 times. 16 minus 3 will be our answer, which is equal to 13. So we're done with that. And now we go to number 22. We have 2 minus the square root of 6 squared. So again, we have a term that's squared, which means that is equal in expanded form to 2 minus the square root of 6 times 2 minus the square root of 6. So just like we did in the last problem, we will set up a box to do our products. And so we set up our rectangular box, and each term represents a length. So we have 2, and we have negative the square root of 6 horizontally, and vertically we'll have 2 minus the square root of 6 vertically. We get each of the products. 2 times 2 is 4. 2 times negative square root of 6 is negative 2 times square root of 6. 2 times negative square root of 6 is negative 2 times square root of 6. Negative square root of 6 times negative square root of 6 is 6. We combine the like terms. We first want to write each of them. The like term will be 4 plus 6. Then we have negative 2 times square root of 6 minus 2 times square root of 6. We combine the like terms. We'll be left with 10 minus 4 times the square root of 6. And that is our final simplified answer. So there we go. What's next? Let's do 23. So 23, we have the square root of 8 plus the square root of 2. Oh, I'm sorry, we're doing 24. We're skipping 23. So we're doing square root of 6 square root of 6 plus 4 times square root of 5 times 4 times square root of 3 minus the square root of 10. So again, we have 2 by 2, so we will create a box and create our 4 products. Vertically, horizontally, we'll have the square root of 6 and 4 times square root of 5. Vertically, we'll have 4 times square root of 3 and negative square root of 10. We get each of the 4 products. 4 times the square root of 3 times square root of 6 is 4 times square root of 18. 4 times the square root of 3 times 4 times square root of 5 will give us 16 times the square root of 15. We multiply each of the like terms. Negative square root of 2 times square root of 6 is negative square root of 60. And negative square root of 10 times 4 times square root of 5 will be negative 4 times the square root of 50, which is basically 5 times 10. So we write each of those terms down. Now at this point, we can simplify the perfect squares or radicals. So for instance, 18 can be written as 9 times 2. 60 can be written as 4 times 15. And 50 can be broken down into 25 times 2, which will pop up here in a sec. So we have 4 times the square root of 9 times 2. Can't simplify square root of 15. 60 can be written as 4 times the square root of 15. 4 times 15, and then 50 can be written as 25 times 2. So now we simplify the radicals. We break down the factors into separate radicals. The square root of 9 is 3, so we have 4 times 3 times square root of 2, plus 16 times square root of 15, minus 2 times the square root of 15. Then we'll have minus 4 times 5 times the square root of 2. We simplify the products we can do. 4 times 3 is 12, so that's 12 times the square root of 2, plus 16 times the square root of 15, minus 2 times the square root of 15, and minus 4 times 5 is 20 times the square root of 2. So 2 of these are like, we have 2 pairs of like terms. So we want to group those together and get our final answer. As you can see, I'm moving it above there so we can have enough room to simplify our answer. So what we will do now is write what we have left. We want to group those terms together. So we take 12 times the square root of 2, and we're going to group that with its like term, which we just had, which is negative 20 times the square root of 2. We group those together. And then we want to group the other pair of like radicals, which is 16 times the square root of 15 minus 2 times the square root of 15. So because we have like radicals, we factor out the square root of 2 in the first group, and we're left with 12 minus 20, which we will simplify. We factor out the square root of 15 in the second group, and we write 16 minus 2. 12 minus 20 is negative 8. So because that's negative, we'll put the 16 minus 2, which is 14, times the square root of 15, and then we'll put negative 8 times the square root of 2, which gives us our final answer. And so we have mastered the concept of solving operations with radical expressions. We've done a variety of addition, subtraction, and multiplication problems. And so I wanted you to feel comfortable and do a different variety of problems. You should feel much more comfortable with this process of simplifying radical expressions with the 3 major operations. You don't really divide. So we're done with another math adventure. This is the NOLA Mathman signing off. Have a blessed day, and until we meet again for another math adventure, have a nice, prosperous day. Bye-bye.
All right, perfect timing.